to homework help for lesson 7. What comes next and what comes later? All right, so what is assigned for today? We're going to start with number 4. All right, so from the ready portion, find the common ratio for each geometric sequence. Now, right off the bat, it's already telling us that this is, let's get our green ready. It's already telling us that this is a geometric sequence. Oh, that's not the rating tool. There we go. That it's a geometric sequence, and we're looking for a common ratio. So we're doing like multiplication or division. That's what we're talking about. So for number 4, if we're at 40 and we're dropping down to 10, we could say that that's minus 30. But it's telling us it's a ratio, and this is a geometric sequence, so that's actually divide by 4, right? So the common ratio for this one, from 40 down to 10 is dividing by 4. From 10 to 2.5 is also dividing by 4. So we just need to write divide by 4, right? Or we could write multiply by 1/4, right? Those are the same thing. So we could write either one. Onto the set. All right, fill in the blanks for each table and identify the type of sequence. Then write the recursive and explicit equation for each sequence. All right, so it looks like on the first one we have 1, 2, 3, 4, 5. So the top row is just exactly as we like it, right? It's all things in order. That's good. On the bottom row, our outputs, our y values, we have 15, 18, 21. That to me looks like plus 3, plus 3, plus 3, right? Oh, that didn't write quite how I wanted it to. Actually, none of these are. Let's see if we can, there we go, plus 3, plus 3. So this tells me the type of sequence. This is arithmetic. Arithmetic. All right, arithmetic. And then if we add 2 more, that's going to be 24 and 27. All right, our recursive form is going to be f of, it says x and y, but we'll still use n, that's fine. F of n equals f of n minus 1 plus 3, because we're adding 3 each time. And then we should note that f of 1 equals 15. And for our explicit form, well, we're going to start with our jumps of 3 each time, mean that we're going to have f of n equals 3. That's our jump, 3n. 3n, and then we just need to know, what are we starting at? Well, if we start at 12, right? If we start at 12, then when we add 3 and we plug in 1, right? If we add 3 to that, we'll get to 15, right? But basically, if we plug in 1, we'll have 3 plus 12, which is 15, which we know needs to be the case. So that's the solution to just number 1. Our next is number 7. So here we go. We've got 1, 3, or 1 and 3 match up, 2 and 9, 3 and 27. So our sequence is 3, 9, 27. The gap from 3 to 9 is only 6. So the gap from 3 to 9 is 6, but 9 to 27 is, looks like 18. So that's not going to be arithmetic. So we know that this is going to be, type of sequence, this is going to be geometric. So geometric. There we go. And we're multiplying by 3 each time, right? 3 up to 9 is times 3. 9 to 27 is times 3. So we know that we're going to go to 81 here. And then 1 more times 3 is going to give us 243. Okay, the recursive form of this is going to always start with f of n equals f of n minus 1. And then what are we doing to that f of n minus 1? We are multiplying it by 3. And we should note that f of 1 in this case equals 3. right? So our first number is 3. And then explicit, which can be a little bit trickier, but in this case is pretty straightforward, is just whatever you have for your step number, you're just going to do 3 raised to that power, right? So f of n equals 3 raised to the n. And that works out for, right, it works out that if we plug in 1, we will just get 3. So that is pretty straightforward and a good time to use explicit functions as far as efficiency is concerned. So that was number 7. So we skip over and we are at number 8 now on the next page. So let's zoom in here. All right, number 8. We're starting with 48, then down to 12, then down to 3. All right, so this is definitely dropping. So we're either looking at subtraction or division or maybe multiplying by a fraction, something like that. So let's see. If we were going to do subtraction, we'd have to subtract 36. And okay, so it's definitely not going to be subtraction, because if we subtracted 36 the first time and did that again, we should be at negative something. So, so it looks like we're doing division. So what are we dividing by? It looks like dividing by 4. That'll work there. And yep, it's going to be divide by 4, right? Which means we're going to have to divide by 4 again. And one more here, divide by 4. Okay, so that will be 3/4 is what's going to plug in here. Nope, that's not written very clearly, is it? 3/4, let's rewrite that. 3/4 here. And then if we take 3/4 and we divide that by 4, well, that's actually going to increase the denominator, right? So we can actually write this pretty easily as just 3 divided by 16. And that'll work. So that's 3/16. All right, type of sequence, we're doing division or multiplication by fractions. This is also times 1/4. So type of sequence is going to be geometric. And let's get our functions written. All right, so our recursive is going to be f of n equals f of n minus 1. Yeah, we'll write it as times 1/4. Oh, that is not 1/4, is it? Times 1/4. There we go. And also we should note that f of 1 equals 48. Oh, 48. There we go. And our explicit rule should be f of n equals, now this is where the fun starts to happen. We could have 48. Oh no, sorry, not 48. What am I saying? Sorry, it should be 1/4 to the n. All right, 1/4 to the n, but then we need, when we plug in 1, it has to become 48. That's a little tricky, right? Because if we plug in 1 right now, it's going to be 1/4. So what if we do this and we add times 48? If we do that, is that going to be enough? Well, 1/4 times 1 is 1/4 times 48. That's going to be 12. So that's actually our second term. So we need to move the term over by 1, so we can write minus 1 up here. There we go. And now this will work. If we plug in a 1, we're going to get 1/4 to the 1 minus 1, which is 0. So that's 1 times 48. So that'll work. Or we could always rewrite this as f of n equals, and we could actually do 48 times 4 and have that as our multiplier. But we don't need to do that right now. But it is a solution that would work. All right, here we go. Add 2 more points on the graph that fit with the sequence. identify the type of sequence, and write the recursive and explicit equation for each sequence. Wow, okay, so we're adding 2 points. That's the first thing. We're going to end up doing that in orange, I think. Add 2 more points. Identify the type of sequence. That's okay. All right, so, and then everything else that we've been doing, but now we're going from a graph. So it looks like we're going over 1, down 2, over 1, down 2. So let's go over 1, down 2 more. Oop. And over 1, down 2 more to there. There we go. All right. So those are our 2 more points. And now the type of sequence. Well, since we're always subtracting, it seems like we're going down 2, down 2, down 2, down 2. That actually tells me that it is arithmetic because we're just doing subtraction. We're subtracting from 9, right? 9, and then we're going from 9 down to 7, and then from 7 down to 5, and then 5 to 3, and 3 down to 1, right? So it's always the same gap. So this to me is arithmetic. Arithmetic. All right, and now let's go and write our rules. So our recursive form, f of n equals f of n minus 1 minus 2, because we're subtracting 2 each time, and then f of 1, right? Our starting point was 9, right? Let's go back up and check. Yes, we started out, if we plug in 1, we should get 9. So there we go. And then explicit, we'll do this in a different color, that's fine. F of n equals, well, we're always taking off 2, so it's going to be negative 2, because that's like our slope. So negative 2 n. And then what are we starting at? Well, if we go up here, it looks like we need the first number. If we plug in a 1, we need to get 9. So this would be negative 2. So it actually has to be that we start even higher. We must start at 11. So plus 11. All right. There we go. That is done with number, what was this? Number 9, I think it was? Yep, number 9 is all set. So let's go and see. All right, this is 10 and 11. All right, those were not assigned, so we keep going. 12 was not assigned. 13, here we go. All right, I think this is the last one. Claire has $300 in an account. She decides she is going to take out $25 each month. Ooh, okay, so we have to write our recursive rule, our explicit rule, and graph it. All right, we can do that. So let's start out with our recursive rule. Always going to start out with f of n equals f of n minus 1. All right, and now what are we doing? She has $300 in an account. She decides she's going to take out $25 each month. All right, so let's say that she starts, right? Let's go with the age of her account, if that makes sense. So let's say that the month, she takes out 25 each month. So let's say she like takes out 25 at the end of the first month, right? So like she starts with 300 and then at 1 month, she takes out 25. Does that make sense? So we're gonna write it like that, but actually, you know what? Before we decide on that, let's see. What does it say? Does it give explicit instructions here? Write the recursive and explicit functions for each sequence. Oh, it tells us that they're arithmetic. That's good. Then graph each and label the axes. All right, so it doesn't actually say which of, like whether we should say that 300 occurs at month 1 or at month 0. So I'm going to say it happens at month 0. So anyway, here we go. The function of n equals the function of n minus 1 minus 25, right? Because she's taking out 25 each time. And then f of 0 equals 300, right? That just means that we should add on that this is dollars. And then this is months of account. So that's good. There we go. So our recursive is done and our labels are on the graph. That's good. So now we switch over to our purple to write our explicit. So explicit function f of n equals. Now we're going to lose $25 each month. Or not lose it, but she's going to take it out. So minus 25 times the number of months, right? And the number of months is n. So she's going to take $25 per month out. And then we just have to make sure, like, what are we starting at? Well, we start at 300, right? And this is why I used 0 for 300, because like it's if no months have gone by, right, then we should be at 300. If 1 month has gone by, then we're at 300, but we took 25 out one time. So that's why I used f of 0, right? Or I used sort of the number of months that have gone by. I decided, oh, well, when no months have gone by, that's when we have $300. So, okay, that is our that is going to be our explicit formula. Now for the graph. Let's add points here. So the first point should be straightforward. Her account at 0 months in, her account has, oh, that's not quite right. Let's make this a little bit bigger, maybe make it a 3, that's fine, right? So 0 months in, she's at $300. Then after 1 month, she should have lost $25. At 2 months, she takes out another 25, another 25, another 25, right? And it's arithmetic, which means the same step down each time. And it looks like, according to our graph, she should run out of money in her account after 12 months. And I think that makes sense because 12 times 25 is 300. So those are your answer key little helps and hints for today's homework output video.